This video explores two powerful neural network architectures, temporal graph networks and pixelCNN. Temporal graph networks are used for processing sequential data, while pixelCNNs are used for image manipulation and generation. So we'll discuss how these architectures can be combined to make predictions about the future based on the past data. So let's get started with what is temporal graph network. Now this temporal graph network is a type of graph that represents the relation between the nodes or entities and their evolution over the time. It is similar to a regular graph where nodes are connected by edges to represent the relation between them, but it also takes into account the temporal aspect of those relationships. In the temporal graph, the nodes and edges can change over the time, reflecting the evolution of relationship between the entities. And this can be helpful for analyzing how the relationship between the entities change over time. For example, in social networks where the relation between the people can change as they form and break connections over time. Now, this temporal graph network are often used in various fields such as social networks, transportation, biology, finance, etc. They can be represented using various types of data structures such as directed or undirected graph, weighted or unweighted graphs, and can be analyzed using various techniques such as graph algorithms, machine learning, and data analytics. So to summarize this, we can say temporal graph network is a type of graph that takes into account the temporal aspect of the relationship between the entities, allowing for a more complete and dynamic analysis of data. One simple real-life example of a temporal graph network is a social network like Facebook. So in this example, nodes represent individual users and edges represent connections between them, that is friendship. The temporal aspect comes into play because the relationship between the user can change over time. For example, consider the user who becomes friends with another user on Facebook. This creates a new edge between the two nodes in the graph. Over time, the user may unfriend the other user, which would remove the edge between them. Additionally, the strength of friendship may change over time, resulting in a change in the weight of the edge. So in this example, temporal graph network allows us to see how the relationship between the users change over time and how the structure of the network evolves as a result. So this type of analysis can be used for understanding patterns of social interaction, identifying influential users, and detecting potential online communities. Now let's discuss what is pixelCNN. Now this pixelCNN is a type of neural network architecture used in computer vision tasks, particularly for image generation and image manipulation. It is a convolutional neural network designed to generate and manipulate images by predicting the probability distribution of pixels in an image. At a high level, pixelCNN consists of multiple convolutional layers, each of which process the input image and generate a probability distribution over the possible pixel values for the next layer. The final layer generates a probability distribution over the entire image, which can be used to generate a new image by sampling from its distribution. Now, this pixelCNN architecture is particularly effective in tasks such as image impainting, where the network is used to generate the missing parts of image, and image super resolution, where the network is used to generate a high resolution version of low resolution image. It has also been used in other computer vision tasks such as image classification and object detection. Now, these pixelCNNs are based on the idea of recurrent neural networks, which are commonly used in NLP tasks. So in particular, pixelCNN use a type of RNN called a convolutional RNN, which allows the network to process sequential data such as images in a way that is similar to how RNNs process sequence of words. So one simple real life example of pixelCNN is using it for image impainting. So imagine you have an image of a person holding a sign, but part of the sign is missing. So you can use a pixelCNN to generate the missing part of the sign. So to do this, you would first feed the partial image into the pixelCNN. Now this pixelCNN would process the image using its convolutional layers to generate probability distributions over the possible pixel values for each missing part of the sign. The final layer of pixelCNN would generate a probability distribution over the entire missing part of the sign. The network would then sample from its distribution to generate a new image, which would be a completed version of the original image with the missing part of the sign filled in. Now here the generated image would be as close as possible to the original image based on the patterns and features learned by the pixel CNN during training. And this is just one example of how the pixel CNN can be used in practice, but it illustrates how this type of neural networks can be used to generate and manipulate images in a powerful and flexible way. Thank you.